Okay, so this is part 2. So number 17 says, for the given function f and g, find the requested composite function. So this is a fog problem. So we have f of x equals 7x plus 14 and g of x equals 3x minus 1, and we gotta find f of gx. Okay, so let me write it down. I think I could write it in here. I have enough space. So basically, how to do composition formulas and composition problems, you always start on the right hand side. So you're putting this g of x. Do you see this g of x? You're going to put this inside of f of x. So that's how you do it. So g of x is 3x minus 1. So you're going to put this in f of x. So what you do is, so this is going to equal, wherever you see an x in the f of x, you're going to plug in 3x minus 1. So it's going to be 7 parentheses, and then our x is going to be 3x minus 1 plus 14. So that's going to be 21x minus 7 plus 14. That equals 21x plus 7. So that is your final answer. So yeah, the key is just start on the right side and put it in the other function. Okay, number 18. I have to write this down. It says the function f of f is 1 to 1. Find its inverse. So equals x over x plus 8. So we gotta find the inverse. So simply, first step is see this f of x. That's the same thing as y. So you can write it as y over x plus 8. And then the second step is you switch the x and y. So this y is no longer going to be y, it's going to be an x. And then it's going to be 8 over, this x is no longer going to be an x, it's going to be a y. And then what you do is you just solve for y. So what I'm going to do is cross multiply. I'm going to multiply this by that. So it's going to be x times y plus 8 equals 8. So I want to solve for, and then I want to solve for y, so I'm going to divide everything by x, divided by x. So you get y plus 8 equals 8 over x, right? And then I'm going to subtract 8. From both sides, so you get y equals 8 over x minus 8. And then you can get the common denominator, so you can multiply this by x. So you can get y equals negative 8x plus 8 all over x. And then the last step is replaces f with f of inverse. So f of inverse of x equals this whole thing. That's how you find the inverse. That was 18. Oh. It says this one I have to actually write. So it says determine the domain, range, and horizontal asymptote of the function. So we are dealing with f of x equals negative 2x, negative 2 raise x minus 3 plus 1, 2. So we're dealing with exponential graph. So we are doing, this is a typical exponential. So it's f of x equals -2, raise that to the x minus 3 plus 1. So, okay, so let me review something. An exponential graph has a y-ness of 0, 1, and if it's increasing, it'll go look like this, and then it has a horizontal horizontal asymptote of horizontal asymptote of y equals 0. So it gets pretty close to 0 but never touches. Okay, so let's look at our original graph. So, but the thing is, this -2 means there's a reflection. On x-axis. So what I'm going to do is I'm not going to graph it all at once. I'm going to graph little by little. So what I'm going to do, I'm going to graph f of x of -2x. So f of -2x, since there's this negative, that means there's a reflection. So it's like going to be flipped. So that point is going to be from 0, -1. So it's going to be, our new graph is going to be 0, -1. It's going to look something like this. It still has a horizontal asymptote of y equals 0, right? But our y-intercept is 0, -1. So let's see. So this is the graph of y equals -2x. Now this x minus 3 means there's a horizontal shift of 3 units right. So let's graph that part. So it originally started at 0, -1, so we're going to move it 3 units to the right. So it's 2, 3. So it's going to be, we're going to move it 3 units, 1, 2, 3. So it's going to be, our new point is going to be 3, -1. And it still has a horizontal of y equals 0. Good. Okay, so this graph is y equals -2x minus 3. Now our last graph is our final graph. So there is a vertical shift of 1 unit upwards. So this +1 is our vertical shift of 1 unit upwards. So our final graph is going to look something like this. So we're going to shift this up 1 unit. So this is going to be 2, 3. It's going to be 3, 0. And then we have a new horizontal asymptote of y equals 1. So this point is 3, 0. So it'll look something like this. It has a horizontal of y, horizontal h of a, of y equals 1. And then, so this is our final graph. So it's y equals negative 2x minus 3 plus 1. And then from that, our domain is pretty much all real numbers. So from negative infinity to positive infinity. And the range is negative infinity to 1. So that's how you graph this exponential graph. Okay, so number 20, I guess is another exponential graph. So in 20 it says graph f of x equals 2 minus ln x ln negative 2 ln x plus 4. So what I can do is, this is a natural log graph. So a natural log graph is pretty much like log graphs. So it's pretty much inverses of exponential graph. So remember, exponential graph had a y-intercept of 0, 1. Now, log and natural log are pretty much inverses of exponential graph, so that we will not have a y-intercept, we'll have an x-intercept of 1, 0. So it will look something like this. But we have a vertical asymptote now at x equals 0. So okay, so first step is I'm gonna rewrite this as negative ln of x plus 4 plus 2. So this negative means there's a reflection on x-axis, and then this x plus 4 means there's a horizontal shift. But it's not going to be positive 4, it's going to be negative 4 units. And then this plus 2 is our d, so it's going to be our vertical shift, so it's going to be vertical shift of 2 units upwards. So like again, I'm not going to graph it all at once, we have to graph it little by little. So what I'm going to do is graph negative ln x. So remember, this is a typical regular ln x graph. It has a y-intercept of, it has an x-intercept of 1, 0. But since there's a negative, that means there's a reflection. So instead of it looking like this, it's going to look something like this. Still has an VA at x equals 0, right? Vertical asymptote at x equals 0. So this graph is y equals negative ln x. Now I'm going to plot the horizontal shift. I'm going to do 1, 2, 3, 4, 2, 3. So we're going to move this point 1, 0 to 4 units to the left. So it's 1, 2, 3, 4. So it'll be this point, right? So this is going to be negative 3 comma 0. And then we have a vertical asymptote at x equals negative 4. Now, it's always just, remember, it's 1 less from the x value. So 1 less from negative 3 is x equals 4. So it's x equals negative 4. So it's going to look something like this. Never crosses the x-axis. The vertical asymptote. So this says y equals negative ln of x plus 4. Now we could do the shift, which is our final graph. So we're going to move this 2 units upwards. So at negative 3 comma 0, 1, 2, 3, our vertical asymptote is right here. X equals 4. So we're going to move this 1 unit. So this is going to be no longer negative 3 comma 0, but it's going to be negative 3 up 2. So it's going to be right here, which is negative 3 positive 2. So it's going to look something like this. So our vertical asymptote is at x equals 4. So VA equals 4. I mean, not positive 4, negative 4. And then our domain is parentheses, negative 4 to positive infinity, right? Because it gets really close to negative 4 but never touches, that's why it's parentheses. And then the range is all real numbers. So that's how you graph this natural log graph. That was 20. Let's do 21. 21 says, find the domain of the function. F of x equals ln of 6 minus x, right? So, gotta find the domain. So we can rewrite this as ln of negative x plus 6. So when you graph it, it's going to look something like this. 1, 2, 3, 4, 5. And then at 6, it's one of our asymptotes, so x equals 6. There's a reflection, so it's going to look something like this, like back. So our domain is from negative infinity, right? Negative infinity, and then it stops at our asymptote at 6. So that's how you find the domain. That was 21. 22. Says solve the exponential equation. Express the solution in terms of natural logarithms. we got e to the x plus 8 equals 4. So our goal is to solve for x. So ask yourself, can you get the same base of e? No, for this instance we can't. So we're going to have to use the log rule. But I'm not going to use log. I'm going to use natural log, because when you take the natural log and e, they're inverses, so they cancel out. So that's what we want. So I'm going to do the natural log. I'm going to use the natural log. So the rule for natural log or log is whenever you have an exponent, you always put it in front of the natural log. So it's going to be x plus 8 natural log of e, and then the natural log, then you're going to take the natural log of 4, so it's going to be natural log of 4. So remember, natural log and exponential are inverses, so they cancel and they just become a 1. So it's like 1 times 8, so it's just x plus 8 equals natural log of 4. And then if you wanted to solve for x, you subtract 8 from both sides. So x equals natural log of 4 minus 8. And that's about negative 6.6. That was 22, 23. Solve the equation. So let's see, we're going to solve. So we have log of 4 x plus 5 plus log of 4 x minus 1 equals 2. So my goal is to solve for x. So I'm going to use this rule. Y equals log a of x if and only if a to the y equals x. So before I use this rule, let's simplify this part. Let's put it all in single log base of 4. So it's going to be log base of 4. And then when you're adding logs, you're really multiplying. So you're going to multiply x plus 5 and x minus 4. So it's going to be x plus 5 and then x minus 1, not x minus 4, equals 2. Now we can use this rule. So what this form, does it look like this part or this part? It looks something like this, right? So we can find our a, we could find our x, and we can find our y value. So our a is basically our base, which is 4. Our x value is this whole thing. So it's x plus 5, x minus 1. And then our y value is always the right side or left side of the equal sign, so our y value is 2. Now, if we have it in this side, we could put it, now we have to put it in this form. So we've got to put it a to the y equals x. So a is 4, our y is 2, and our x is this whole thing. Okay, so now let's solve for x. So it's going to be 16. This is going to be x squared plus 4x minus 5. Let's see, subtract 16. So you're left with x squared plus 4x minus 21 equals 0, and then you just FOIL it out. So this is going to be x plus 7 and then x minus 3. So our values of x equals negative 7 and x, our possibilities is negative 7 and positive 3. Okay, so we can never have a negative inside the log, so we can eliminate -7. So let's try x equals 3. So you plug it into the original equation. If you plug it into the original equation, you're going to get log 4 8 times 2 equals 2. So that's log base 4 of 16 equals 2. So that's like really saying 4 to the square equals 16, which is true. So our only choice is x equals 3. So that was 23. So 24 says, write the sum and or difference of the logarithm. Express powers as a factor. So they're pretty much wanting you to expand this. So you have log base 14, the square root of xy over 9. So they pretty much want us to expand it. That's what they want. So first I can rewrite this square root xy over 9 as log base 14 xy over 9 to the 1/2, because that's the same thing. Now remember this 1/2 we gotta distribute it, so it's like multiplying. When you're raising a power to another power, you're multiplying the exponent. So there's a 1 here and there's a 1 over here, so it's going to be log base 14, and then 1 times 1/2 is 1/2, so it's x to the 1/2, and then y1, y times 1 times 1/2 is 1/2, and then you have to just distribute this 1/2 to the 9, so it's going to be divided by 9 to the 1/2. So we have two parts. We have an exponent part, and then we have a multiplication, and then we have a division. So let's simplify this part. Log base 14 x to the 1/2. So remember, in log rules, whenever you have a power in exponential, you put it in front of the log. So it's going to be 1/2 log base 14 to the x. Now see, this x and y are really close. That means they're multiplying. So when you're multiplying, you're really adding. So it's going to be 1/2 log base 14 of y. And then now we are dividing. So when you're dividing logs, you're really subtracting. So it's going to be subtract, and then you put that 1/2 in front of the log. So it's 1/2 log of 9. So this is your final answer. Okay, good. 25 says word problem. So the size of P of a small herbivore population at time in T years obeys the function Pt equals 500 e to the 0.11 t. If they have enough food and the predator population stays constant, after how many years will the population reach 2500? So if you give us this formula, so Pt equals 500 e raised to the 0.11 t. So my goal is to find time. That's my pretty much goal. So we're gonna take our goal is to find time. So okay, so and then they said that when PT was at 2500, so over here we're gonna replace PT by 2500. So I want to solve for t, so I'm gonna first, before I do the before I take the natural log of both sides, I'm gonna divide everything by 500. So 2500 over 500 is 5. This cancels, so you're just left with e to the 0.11t. Now I'm going to take the natural log of both sides. So on this side it's going to be natural log of 5. And then when the natural log grows, so you put the exponent in front of the natural log, so it's going to be 0.11t. And then the natural log of e. Since these are inverses, they cancel, or they're just left with 1. So you're left with 0.11t. And then my goal is to solve for t, so I'm going to divide everything by 0.11. So t is, if you put this in a calculator, you get approximately 14.63 years. So that was 25. Okay, now we're doing trig. So on 26 it says, a point on the terminal side of angle theta is given. Find the exact value of the indicated trigonometric function. So we got to find secant theta, and they give us this point, right? It goes -2, -3. And we got to find secant theta. So remember, secant theta is 1 over cosine theta. So let's draw the triangle for this point. So -2, -3 is probably in quadrant 3. So this is -1, 2, 1, 2, 3. So it's going to look something like this. Now remember, that -2 is our x value, and that -3 is our y value. So it's going to be -2 here and -3. And then you got to find the hypotenuse. So you can do the a squared plus b squared equals c squared. So we can do -2 squared plus -3 squared. Whoops. Yeah. Equals c squared. So that's 4 plus 9 equals c squared. 9 plus 4 is 10, 11, 12, 13, 10, 11, 12, 13, 14. So that's 14 equals c squared. Take the square root of both sides. Oh, this is not 14, this should be 13. So c is square root of 13. Now we can find cosecant. So cosecant is, so first we got to find cosine theta. So cosine theta is x over radius. So our x value is -2. And then our radius is square root of 13. So it's 1 over cosine, which is -2, square root of -2 over square root of 13. This is a compound fraction, so this one has an invisible 1, so it's 1. And then you look at the denominator, so you have a 1 here and a square root of 13. Our common denominator is square root of 13. So this is going to be, so it's going to be 1 times square root of 13 is square root of 13. And then -2 over square root of, so it's like this, -2 square root of 13 times square root of 13. these can't cancel, so you're just left with -2, so that's our denominator. So this is our secant theta. That was 26. Oops. Okay, 27, it says find the exact value of the indicated trigonometric function of theta. So we got to find cosecant theta of -3/2. So we have cosecant theta of -3/2, and our goal is to find cotangent theta. So remember, cosecant theta is the same thing as 1 over sine theta. And then cotangent is the same thing as the opposite of tangent, which is x over y. So first we go to this one's a little bit difficult. This one we don't have a sine or a cosine, so we got to figure it out. Let's try to figure out our sine theta. So remember, cosecant is 1 over sine theta, so it's 1 over, this is where you have to guess and check. What if I say that sine was -2/3? So if sine theta is -2/3, it's going to be 1 over, our cosecant theta is going to be 1 over -2/3. Compound fraction. So you have a 3 here and a 1 here. So our common denominator is 3. So our numerator is 3 times 1, which is 3. And then our denominator is 3 times -2/3, which is 3 cancels, so it's just -2. So we get -3/2, so we know that our sine theta is -2/3. So it was pretty much just guessing. So now we can draw our triangle. So if sine theta is -2/3, we know that sine is y over radius, right? So it'll be in quadrant 3, so okay, so sine is y over radius, so it'll be somewhere like this, quadrant 3. So our y value is -2, and then our radius is 3. We're going to find our x value. We got to find our x value, so we got to do the Pythagorean theorem. So it's -2 squared plus x squared equals 3 squared. So this is 4 plus x squared equals 9. Subtract 4. So x squared equals 9 minus 4, 1, 2, 3, 4. That's 5. Take the square root of that, take the square root of that. X equals square root of 5. And then since we're in quadrant 3, it's going to be negative square root of 5. So now we got to find cotangent theta. So it's pretty simple. So it's pretty much the x over y. So our x value is negative square root of 5. And then our y value is -2. So that is our cotangent theta. That was 27. Let's do 28. You have 2 cosine theta of x equals pi. So it says find the exact solution of the equation. So we're going to find the exact solution. So my goal is to solve for x. So I'm going to divide everything by 2. So you get cosine inverse of x equals pi halves. And then some people can know it from here. So they're asking us some people could figure it out. It's like asking what is the okay, first I want to solve for x. So what I can do is multiply everything by cosine, because when you multiply cosine and cosine inverse, these cancel, so they're inverses. So you're just left with x, and then you have to put times that by, do the same thing on the right, so it's cosine of pi halves. So what degree in radians is going to give you a cosine of pi halves? Is 0, right? 0 or 2 pi is the same thing. That was 28. 29 says find the exact value of tangent inverse of square root of 3 over 3. So we have tangent inverse of square root 3 over 3. So remember, so what they're asking is what degree in radians is going to give you a tangent. What is going to give you tangent of positive root 3 over 3. So I'll give you a visual. What if I use pi 6? Pi 6 has a coordinate of root 3 over 2, comma 1/2. So that's your x and this is your y. So remember, if you take the tangent of that, it's y over x, so it's 1/2 divided by square root of 3 over 2. 2 cancels, so you're left with 1 square root of 3, and then if you want to rationalize the denominator, you multiply top and bottom by square root of 3. So you get square root of 3 over 3. So pi 6 works. Can we use, I don't think we can use quadrant 2 because it's going to give us a negative. So yeah, we'll just use pi 6. That was 28. I mean, that was 29. Let's do 30. 30 says, use the sum or difference formula to find the exact values. So we have cosine of 50 degrees So we're going to use this formula, cosine of alpha plus beta. It's pretty much the sine, the sum of cosine. So that's going to be, we'll call alpha 50 degrees and then beta 10 degrees. So it's going to be so if alpha is 50 and then beta is 10, it should be cosine of 60 degrees. So we know the cosine of 60 degrees is 1/2. That's 30. 31 says, use the information given about angle theta from 0 to pi to find the exact value of an indicated trigonometric function. So 31 says, you have a sine theta of 12/13. Theta is from 0 to 2 pi. Pi half, sorry, not 2 pi. So this only, our boundary is in quadrant 1. So first, what I'm going to do is, so what are they asking? So they are asking, find cosine 2 theta. So we're going to find cosine 2 theta. First, I'm going to draw the triangle. So we know, remember, sine is y over radius. So our y value is here, 12. Remember, this is our x and our y. And then our radius is 13. And then if you did the Pythagorean theorem, a squared plus 12 squared, you get a equals 5. So the x value is 5. So we're going to use, this is what's called the double angle formula. So the double angle formula is cosine square theta minus sine square theta. So let's find our cosine theta. So cosine theta is x over radius, so it's 5 over radius, which is 13. And then our sine theta is y over radius, which is 12 over 13. So now we just going to do cosine square theta, which is 5/13 square minus 12 over 13 square. So that's pretty much 25 minus 169 minus 144 over 169. So cosine 2 theta is negative 119 over 169. That's your final answer. That's 31, 32. Solve the equation. Give the general formula for all solutions. So they want all solution. So we are given cosine theta minus 1 equals 0. I want to solve for theta, so first I'm going to add 1. So you get cosine of theta equals 1. And then to find theta, you can multiply everything by cosine inverse. So this cancels, so you're just left with theta equals cosine inverse of 1. So what this really is saying is what degrees and radians is going to give you a cosine of positive 1. So our only option is 2 pi, right? Here's 2 pi, which is coordinates of 1, 0, which is cosine of 1. But they ask us for all solutions, so this is where you're going to do the 2 pi k thing. Because when you set k equals 1, that's 2 pi, which is about 360. So if you start from here and you went 360, you're still going to get a cosine of positive 1. If you do cosine of 2, you go to unit the circle twice, you still get cosine of 1. So that's why we use 2 pi k, because we want all solutions. That was 32. '33 is solve the equation. So we have sine of theta equals square root of 3 over 2. This is pretty simple. You know that in the unit circle, it's like what degrees. If you wanted to solve for theta, you're going to do theta. You can multiply everything by sine inverse. So theta equals sine of inverse of square root of 3 over 2. And if I draw the circle, where it's going to give you, what degree and radians is going to give you a sine of positive root 3 over 2, we can use pi thirds, by 6, by 4th, pi thirds. Pi thirds right here. So it's 1/2, comma, root 3 over 2. This is pi thirds. And then where else can we use 2 pi thirds? So this is 1/2, negative 1/2, comma, positive root 3 over 2. I don't think we can use quadrant 3 or quadrant 4. So for pi thirds, theta is pi thirds, but we're going to add 2 pi k. Because from 2 pi k, let's say you want it from here, you want the unit circle once, you're still going to get a sine of positive root 3 over 2. So that's why it's 2 pi k. And from here, it's 2 pi 3 plus 2 pi k as well, because of the same reason for this part. So that's your final answer. Uh, 34. Oh, that was 33. So 34. Solve the equation in the interval of 0 from theta 0 to 2 pi. So we're given 2 sine square theta equals sine of theta. And our boundaries is from 0 theta from 0 to pi. So basically you're going to the unit circle just once. So first I want to solve for theta. So what I can do is divide both sides by sine theta. So you get 2 see, you're just left with sine theta equals 1 divided by 2 divided by 2. So you get sine of theta equals 1/2. And then you can multiply everything by the sine inverse. So theta equals sine inverse 1/2. So it's saying what degrees and radians to give you a positive sine of 1/2. And that our only options is pi 6 and 5 pi over 6. So what is the y-intercept of cosine x? The y-intercept of cosine x is just 0, 1. Actually, I could write it right here. So a typical cosine graph will look something like this. It has pi half, pi, 3 pi halves, and then 2 pi. So it starts at here and goes like this. So we only care about the y-intercept. So the y-intercept is at 0, 1, and then, or you could just always set 0 for x and you get a y value 1. I could do 36 right here. So cosine of x, so if we multiply everything by cosine inverse, we're going to get x equals cosine inverse of 0. So they're asking what degree and radians. It's going to give you a positive value of cosine 0. Our only choice is pi halves and 3 pi halves. So that was 36. 37. One is to graph a tangent graph. And I'm just going to graph one cycle. So remember, period is different from sine and cosine graph. It's pi over b, right? So our pi over b is pi over 4, because our b is 4. Our critical point is how much we add for each point. So it's the period, which is pi over 4, and you divide that by 4. And you will get a pi 16th. So that's our critical point. Now, we got to find our vertical asymptotes. So remember, we got to find, our goal is to get pi halves and 3 pi halves, because for our x values, our goal is to get pi halves and 3 halves, because that's when it's undefined, right? Because pi half is at 1, 0. If you take, pi half is 0, 1. And if you take the tangent of that, you get undefined. So we gotta pick an x value that gives us a tangent of pi halves. So what I'm just gonna use pi eighths. The reason why I'm gonna use pi eighths is because when you y equals 2 tangent of 4 times pi eighths, this reduces to tangent of pi halves, which is what we want because we want it to be undefined. So we can use pi eighth, and we can also use negative pi eighths. So when you graph it, it's going to look something like this. So one of our asymptote is pi eighths, so it's pi eighths right here. And then also our another asymptote is at negative pi eighths. Okay, we found our asymptote. Now remember, tangent graphs can either go like this, go up like this, or we could go down like this. So this is where we have to use our test points. So remember, our critical point is pi 6, so we can use positive pi 16th. And then we can also use negative pi 16ths. And then we can also use 0. So let's start with 0, 0. So if you plug in 0 into the function, you get 0. If you plug in pi 16th, you're going to get positive 2 on the y value. And if you do negative pi 16, you're going to get negative 2. Like this. So now we know it's going to look like this. Okay, so that's how you graph a tangent graph. Now I've got a graph, sine graph. We got to graph this. So our amplitude is the absolute value of 3, so it's just 3. We have a vertical shift of 5. So our max is 3 plus 5, which is 8. And our min is negative 3 plus 5, which is 2. And then our period is 2 pi over b. So our period is 2 pi, and our b is 1. So it's just 2 pi. And then our critical point is period over 4. So our period is 2 pi over 4, which is pi halves. Now, I think we can graph it now. Blah. So we're gonna have we're gonna have 4 points. So we're gonna have 4 points. 1, 2, or a total of 5 actually, including 0. So 1, 2, 3, 4. So our first point is always starting with the critical point, which is pi halves, and then our last point is always the period, which is 2 pi. So to figure out this point, you just add pi halves plus pi halves, which is pi, and then pi plus pi halves, which is 3 pi halves. And then we know our max is 8, 2, 3, 4, 5. So this is 8. And then our min is 2. Here's 2. So now you gotta figure out, to find the y value, you pretty much just plug in, to find the y value at pi halves, you plug in pi halves into the function. So our first point is pi halves, and then when you plug that into this function, you're going to get a positive 8. Second point is going to be pi, and when you plug in pi into the function, you're going to get positive 5. Third point is 3 pi halves, and when you plug in 3 pi halves, you get positive 2. And then fourth is 2 pi, and then when you plug in 2 pi into this, you get positive 5. And then our fifth is 0, and when you plug in 0, you get positive 5. So now you can graph it. So pi half is at 8, pi is at 5, so I'll call this 5. And 3 pi halves is at 2, so let's do it right here. And then 2 pi is 5. And then at 0 it's 5. So it's going to look something like this. Whoops. And if you want more cycles, you could just do negative pi halves, negative pi, negative 3 pi halves, etc. And then you know that at negative pi halves, it's the opposite of pi halves, so it's going to be negative 8. So negative 8 would be right here if you wanted more than one cycle. So you could just graph one cycle. So that's how you graph this sine graph. Let's do okay, so I'm not going to do, for number 40, I'll give you like some help, but then you could do the rest. So on number 40, we have y equals negative 4 cosine of x minus pi halves. So let's see, our amplitude is absolute value of negative 4, which is 4. Our phase shift is to find the phase shift, you set this x minus pi half to 0, so it's just pi halves, positive pi halves. We don't have any vertical shifts, so our max is at 4, and our min is negative 4. Our period is 2 pi, and then our critical point is period over 4. So our period is 2 pi over 4, which is pi halves. So that's how much we're going to add each point. So here our max is 4, so 1, 2, 3, 4, and then our min is 1, 2, 3, 4. This is negative 4, this is positive 4. Now, let's see. Our first point is pi halves. Now, since there's a phase shift, since this is phase shift, our last point is phase shift plus period, which is pi halves plus 2 pi, which is, you're going to get 5 pi halves. So since there's a phase shift, we're going to have 2, 3, 4, 5. We're going to have 6 points. To total 6. 1, 2, 3, 4, 5. And the 6th point is 0 at 0. So our last point is 5 pi halves. So what you do is, from pi halves, you always add the critical point. So pi halves plus pi halves is pi. Pi plus pi half is 3 pi halves. And then 3 pi halves plus pi halves is 2 pi. I'm not going to complete the graphs because you already have everything. You just need to plug in the y value. So from at pi halves, for example, first point is pi halves. When you plug in pi halves into this function, you can do the rest. You can find the y value. So that was 40. Let's do 37. Let's do some trig stuff. So on 41, it says simplify the expression. So you have 1 plus cotangent theta minus cosecant theta, cosecant square theta. So when you first, we're going to FOIL this out. This is a perfect square, so it's going to be 1 square, which is 1, and then minus cotangent square theta. So when you FOIL out this, you get this. And then bring down this negative cosecant square theta. And then I'm going to use this identity, 1 plus cotangent square theta equals cosecant square theta. So we know that cosecant theta is this thing, right? So I'm going to distribute this negative and then plug in what cosecant theta is, which is 1 plus cotangent square theta. FOIL this out, you get negative 1 minus cotangent square theta. Let's say the 1's cancel, so you're left with negative 2 cotangent square theta. Okay, 42. So on 42, you're given given 1 minus cosecant square theta minus 1 over cotangent square theta. We got to figure out what this means. So I know that this thing, 1 over cosecant theta is equivalent to secant square theta minus, and then 1 over cotangent square theta is the same thing as 1 over cosine square theta over sine square theta. Compound fraction, so I'm going to multiply top and bottom by sine square theta. So it's going to be minus sine square theta over cosine square theta. Bring this down. So secant square theta minus, this is another way of saying tangent square theta. And then I'm going to use this identity. Tangent square theta plus 1 equals secant square theta. So we got to kind of make it look like this. So if I subtract tangent square theta, you get 1 equals secant square theta minus tangent square theta. So this looks like this. So you just replace that, so that equals 1. So that's your final answer. Okay, 43. I'll just call it, I'll do part 3.